ejection. And sometimes there are very intense bursts of energy on the sun. And it's difficult to synchronize the cat sneeze with the explosion, but there, we got it pretty good. So these bursts of energy are what we study in space weather, right? Those affect the Earth, and I'll describe how that happens shortly.
The first one is from Mr. Kajan Lakhan. It's thank you, Dr. Snow and SANSA. The James Webb Space Telescope uses infrared wavelength. What wavelength is used for our sun measurements? Thank you. That's the first question. Must I read all, or are you just going to answer that one?
Yeah, let me answer that one first. So yes, you're talking about the new James Webb Space Telescope. So it is looking primarily in the infrared at distant stars and so on. So of course, we actually do measure the sun's brightness in all wavelengths, including infrared. But most of the images that I showed were from ultraviolet and extreme ultraviolet. So the infrared radiation from the sun comes from the deep in the surface, kind of under the visible light surface, and it's very stable. It changes very little. The magnetic storms occur above the surface in what we call the chromosphere or the corona. That's where the gas is very hot and it's lower density, so the plasma is confined to the magnetic field. So when the magnetic field gets twisted and reconnects, releasing energy, it's from the areas where the ultraviolet light is coming from. So that's why I showed all ultraviolet and extreme ultraviolet images instead of infrared. On the sun, since it's a normal mellow star, the infrared light changes very little over the solar cycle. The ultraviolet will change by a factor of 10 or 100, whereas the infrared changes by a tiny fraction of a percent over the solar cycle. So it's very stable. So that isn't really what produces the space weather events.
No. The second question is from Lakhan again. Does our sun cause gravity?
So maybe I changed the wording just a little bit. So gravity, right? All mass in the universe produces has a gravity field, and the sun, the particles that form together to make the sun all together produce a big gravitational field. The force of gravity is what causes the fusion in the core, and the gravity from all of the material in the sun is what keeps the planets in orbit around it. So the sun is big. It's 99% of all the mass in the solar system. All of the planets together only are like 1% the amount of mass as in the sun. So yes, the sun's gravity field extends throughout the solar system, and that's what keeps the planets orbiting nearby.
Thank you, Dr. Snow. And we have one last question from Mr. Kajan Lakhan. A magnitude M3 earthquake releases 3 billion joules of energy. About how much of energy does a space weather event release?
That's a good question, and I don't have the answer. That's interesting. Is it more or less energy than in an earthquake or a hurricane or something? Because it's affecting the atmosphere at the edge of space, which is lower density, so it doesn't take as much power to cause a big disruption in it. I'm not gonna try and guess, because if I say a number, it could be wrong by many thousands. So the answer is I don't know, and that's an interesting thing to think about. Thank you.
Thank you.